Well, hey there, you guys. This is Mrs. Grady, and she is recording from the smartboard in her very own classroom. Very excited for our inaugural recording here to help you with some of your homework. Now, you notice that I kind of ignored the multiple choice ones. I figure you got to figure those babies out. All right, not too bad, but I'm definitely ready to help you with the math. So let's take a look at some of these horizontal questions and see what we can see. All right, so a diver running 1.5 meters per second, horizontal dive. They give you the time for the water. You want to know how high the cliff was, and then you want to know how far from the base did he hit the water. Okay, so this is actually asking for what we like to call the range. And this, of course, is the height of the cliff right here. So if we drew a picture, it would look, we've got our velocity of 1.5 meters per second, and it's all in the horizontal direction. And this person or whatever it is, it's going to make that half parabola. Okay, so that's the key that we're looking for. So we always begin with graphs, and let's put in what we can put in. Okay, so start with the xt graph. That's going to look like a rectangle, right? We've got 3.3 seconds because the time is given to you. You're looking for the range, which is our second question. We don't exactly know what that is, but I bet we can figure it out pretty quickly because you notice they give us the velocity. Huh, I wonder how that changed to blue. That's interesting. I'm still just holding the black marker. Whatever. Anyway, if we are taking a look at this, we're just going to use the area under the curve formula for a rectangle in order to find it, and that's going to give us our answer to right here. So easy peasy there, man. That's a softball question. Hopefully you had that one. All right, if we look at this in the y direction, remember, we're starting from rest in the y direction. Your initial y velocity for any horizontal projectile is 0. Okay, I still don't know why we're getting that blue thing in there. Well, whatever. It's just making me a little crazy. You know me. I'm a little OCD. All right, so the 3.3 seconds, that's the part that so strange. That's the part that transcends both graphs. All right, it goes to both. And let's see, we want to know how high was the cliff. So what we're looking for here, all right, still weird, is Vy, or is delta y. We want to know how high it goes. What we do not know is Vf. Okay, so let's consider what we also know here, which is the fact that gravity is our acceleration. So, right, we can use our slope graph, or our slope formula, sorry. We know this. That should be pretty easy peasy to find VF. Once we have VF, we can use our area under the curve to find it. And you will have both the base, which is the time, and the height, which is the velocity. So hopefully that helps you with that one, and you should be good to go. Second question. 30 meters from the base, what is the ball's original speed? You know what? When you're doing horizontal projectiles, there's only so many permutations of these types of questions. The key thing is what information do you know and which information do you not know? So it's the same idea, right? But let's think about what we know now. We know 56 meters for the height. We know down here 30 meters for the base. And we want to know Vx. Oh, swipe of blue. All right, so Vx, I do not understand, you guys. I don't even have a blue marker. That's like the one thing that's missing. So maybe the smartboard is having a moment because it's like, where is my blue marker? I don't know. All right, so we're looking for this value here. All right, we know that the area under the curve is 30 meters. We do not know the time as of this moment. Okay, but we do know that the 30 meters will be equal to Vf or Vx. Let me change that actually. Come to think of it, let's change that. Because there's no F, right? It's all the same, times the time. So you need both of those. Since we are really rather limited now in what we can do with the x direction, it's time to go to the y direction. And the y direction will help us figure out the time. Okay, so again, the negative 9.81 meters per second squared. And we know how tall this is. It's 56 meters. We do not know time. We do not know v. But here, we can use our slope. negative 9.81 TF equals VF. All right, so there's the one equation, and then we can use, and it's negative because it's dropping, not because I made some new weird thing up. All right, VF, TF. Put this right here. All right, so you're going to get 1/2 times negative 9.81 TF squared. You're going to use this eventually to solve for T. Once you solve for T here, you have solved for T here. And then voila, you can figure it out. All right, so you could keep going in the y direction and figure out the velocity in the y, but it's not necessary. It's not part of any of the rest of the question. All right, so hopefully that gives you some hints on that one. I usually get the most questions about this one, right? Because the spy and the speedboat being chased down the river, blah, blah, blah. Okay, so it's like a spy movie, right? So here's this cliff, and we've got boat number 1, and we've got boat number 2, and let's see. Faster craft. All right, so the waterfall, 6.1 meters. And we've got the spy at 16 meters per second. And let's just change this. Let's make this is the government boat, it's 29 meters per second. Now, keep in mind what's going to happen. Let's consider the height of the cliff is the same for both. We know that that means that the time is the same for both of these crafts in the air. Yes? Yes. Now we figure if they're in the air for the same length of time, this guy's going to land here. Okay, that's supposed to be green. I should have put the green marker down. My bad. Let's try that again so that it's a little more visual, shall we? I'm still learning. I have my new toy. All right, that one's going to land out over here. We are being asked to figure out how far apart these are. Right, so you're going to have to subtract the two positions. That's the key. All right, so what are we going to figure out? In fact, let me change that color altogether to make it even easier to see. I hope so I can be a little more consistent. This is what we want for our final answer. This is the final answer. We still have a ways to go. All right, but let's consider what we want to do is figure out how far does this boat go? All right, and then you need to figure out how far does that boat go? And obviously then you're going to subtract the two. Okay, so let's keep the middle piece in our heads. Same time in the air for both because the height of the cliff is the same, but they have different horizontal velocities, so they land in different positions. And I need to know the difference between them. We want to know how far apart they are. So I'm going to give you some generic setup, and then you will apply it to both the spy boat and the official boat, right? So let's consider. For both boats, in the horizontal direction, it looks like this. Now, how far they go, the range, that's different, right? This boat, remember we said this boat is different than this boat. So I'm just going to keep this super generic. All right, the time in the air, we don't know it right away. The Vx, we know those. Right, we know what the value of the Vx is for each of the boats, but you have to do this twice. What you do not have to do twice is the y direction. Because since, oh, there we go again. All right, so since we have this boat, both of the boats going off the same exact spot, right? They are falling the same 6.1 meters. Did I really write that down properly? I guess I did. Okay, your goal here is going to be to find the time. We're going to use the steps, actually, the same darn steps. Let me go back a page here. We're going to use the same darn steps we did here, where you're using the slope equation, and then you're going to substitute in the area. Now, don't be fooled. You don't put 56 in there, right? But it's the same idea. You're going to have negative 6.1. So you're going to be using the same slope equations and the area under the curve equations, VFTF. All right, and this one, you're going to rearrange this one, and you're going to put it into that one, just like we've been doing repeatedly. What that will get you is your time. Once you have your time, you're going to put it right there, and you're going to figure out the delta x for each of the boats. Do it twice. Once for the spy boat, once for the government boat. Then subtract the two. There we go. All right, so hopefully you found that helpful, and come in and see me if you need some help.